Hello, and welcome to T1F1-34's final design project. For our project, we designed a self-stabilizing pen for the elderly with limited fine motor function.
In order to understand the needs of our users, we gathered feedback in 3 ways. We first spoke with our grandparents to learn more about the daily challenges older adults face, especially those with hand tremors. We also conducted an online survey using Google Forms and shared on the Reddit page, our Ask Old People. In addition, we visited the Okanagan Chateau Retirement Residence and talked to the residents in person. Based on this stakeholder engagement, we found that the top design priorities were functionality and ergonomics, while modularity and portability were not as strongly desired.
Our first prototype was our screw mechanism. The screw mechanism is repeated multiple times throughout the pen, so making sure we get this right was paramount for our project. The screw uses M10 1.0 thread, 3D printed, offset here to ensure accurate screwing, and female thread all the way up to the top of the female connector. Through about 1 week of repeated use, screwing on and off, well past the lifetime of what a pen would expect, there is some damage to the very top bit of this thread, but it still screws in perfectly and seamlessly, so this will work very well for the lifetime of the pen. Our next prototypes were the ball bearing fittings. 4mm ball bearings, one offset with 1mm in, and one offset with 1.25mm in. The one offset with 1.25 had significantly better rollability and fitting, so we chose to follow through with the 1.25mm offset.
Here we have the completed pen. The pen consists of 3 major parts, which include the bottom support, consisting of the quad support, 4mm ball bearings housed in each leg, the pen tip, and the quad support adapter. Moving up, we find the suspension section, which includes a spring spacers, and a cartridge, all housed in a metal shaft, which also adds weight. Finally, at the top, we find the counterweight, which consists of 2 halves housing a 10mm ball bearing, which also adds weight at the top.
Our pen prototype utilizes 7 different 3D printed components. Due to this being a prototype, these parts were printed using PLA filament for its cheap pricing with adequate reliability. The printer used a 0.08mm nozzle to ensure intricate detail and low tolerance in the prints. These parts took approximately 8 hours to print using 60 grams of filament. Overall, this provided reliable parts to demonstrate a working model of our product.
Precision in writing starts with stability. To do this, our modular pen uses inertia to create a smooth writing feel. In its core, we designed an internal suspension system that acts as a shock absorber to dampen tremors and provide constant pressure when writing. Additionally, we created a 4-legged support system to make a wide, stable footprint. This also provides the added benefit of lowering the center of mass, making the pen feel more stable when writing. Unlike typical pens that require high motor function, these supports do the hard work for you. By combining both a heavy mass and suspension, we've effectively removed the need for a hard grip and high focus when writing. The result is a pen that glides and ensures legibility during every single stroke.